Hello, my name is Job Albar, and I'm a junior computer science major. And for my mid-program project, I decided to create an auto dispenser. Now, some of my earlier ideas before ultimately deciding on the auto dispenser were to create a money counter, a candy color sorter, and a set of smart glasses. Now, my motivation that I finally really decided to do the auto dispenser was one, COVID-19. So because we are shifted from a physical class to an online class, moving everything that I built to 3D and then implementing code for it did become a lot. So I had to downscale my project with the time restraint and moving to a virtual class. Two other key motivations were just laziness and hunger. With the auto dispenser, my honest first thought of its purpose would be food-based, just dispensing snacks, whether it's like M&Ms or like some other candy. So that was really where the idea came from, but it can be applied to other purposes, such as if you had a hardware store and you were, I don't know, dispensing nails, hammers, nuts and bolts. It would be very practical for that. Could be used in stores to avoid contamination of people touching things. Um, yeah, it has a lot of possible uses. So my creative process involved deciding the circuits to use, choosing a project that implemented my choice of circuits, figuring out how my servos was going to dispense the items, and adding pipes to guide the item output. Next, I had to build the input container, attach the servos, Arduino, and the sensor, and then finally add wall mount holes to hold the dispenser itself once it was completed. My parts list was an Arduino Uno R3, 6 copper wires, the micro servo, ultrasonic distance sensor, a screwdriver, 4 short screws, 3 long screws, a laptop to program the Arduino, and a micro USB power adapter. Now, the Arduino is kind of like the brain of the project itself. The Arduino itself is programmed um, to handle the tasks. The copper wires connect the Arduino servos and the distance sensor. The micro servo is what rotates the middle part of the dispenser to dispense. The ultrasonic distance sensor will take in the distance, or it'll measure the distance that something is from the sensor and dispense once something is within a certain distance. The screwdriver, again, just to put in the screws. The 4 short screws put together the sensor body of the project, and the 3 long screws are to hold up the project once it is wall mounted. You'll need a laptop to program the Arduino, and the micro USB with a power adapter is actually the power source for the project. So here are the circuits in the middle. Here we see the Arduino. There's the USB that powers the project. We see the servos that would rotate the center part, and the sensor itself, the distance sensor. Now, the distance sensor, ultrasonic, means it uses sound. So it sends out high frequency ranges, and then it measures the time it takes for the sound to go from the sensor to the item that is hit. Now, my issue was having to convert that frequency time to a distance. So I was able to successfully do that. Some of the challenges I had with my circuit were using a breadboard versus not using a breadboard. Now, as you see, my project is pretty minimalistic, but the breadboard was just a clunky part that would have been stuck in the project. It kind of hurt my design a bit. And then next, I was definitely creating a time triggered dispenser. I wanted to make a time triggered dispenser instead of a distance dispenser, mostly because of like scheduled tasks, like if you left your pet at home and you had to, I don't know, go to work or on vacation or something. having a time trigger dispenser, your pet could be fed breakfast, lunch, and dinner on time every day. But the issue of involving the time with the Arduino is that the Arduino is not connected to the internet while it's being used. So it does not maintain time very well. Now, there were libraries I did find that could improve that and bring time into play, but the Arduino uses a simplified version of C++ that it's a pretty big leap in time use to involve time. Lastly was constantly confusing C++, Java, and Python. Now I typically program in Java. I do like Python also, and I'm pretty new to C++, no prior experience. So when I did begin the project, I was kind of confused with how to program it and my methods I was using, how I was calling them, because some parts really look English like Python, and some parts just look Java-esque. But yeah, those were my challenges. Now, here is the 3D model itself. On the left side of it, we see a container for the Arduino and the servos. Below that, we see the box where the sensor would be. And in the skeleton, we see the holes where the sensor would be looking down at the entrance of the output. At the top, we have the input container where the food and or items will be inserted, and they'll roll through the pipe and come out. Now, the, the sensor would go in here. There was the small compartment that the wires would go through to keep everything connected. The Arduino and servos would be in like the main belly part on the left side, and inside there is kind of a I don't know the proper term for it, but it's kind of like a wheel that just shifts. It has blades on it, and it just shifts out the food. Um, yeah, don't really have a name for it. Here is a view that goes around the project, so you can kind of see more of it. Again, the middle part does have the blades in there. I could possibly take it apart later, let you guys see that. On the back, we do have the holes for wall mounting, and we have our compartments for our circuitry. So some of the challenges I had on the 3D modeling was one, I never used a 3D modeling before, so it was very brand new, starting from complete scratch. I didn't really know where to start. Um, After I kind of got my bearings and tested out and went through a couple tutorials, I jumped right into my project, and immediately what I ran into was hollowing shapes out was very difficult, and making custom shapes that weren't already made. So if we see at the top, there is this kind of hollowed out bowl. That was very hard to make because this hollowed out bowl is actually a sphere that I used a rectangle to cut the top half off. And then I created a smaller sphere to hollow out the sphere. And then I lost the back portion of it, but I needed the back portion. So I had to make a bowl and then make another bowl to hollow out my bowl, if that makes sense. So definitely hollowing out my portions was very difficult and strange. Creating the holes, the screw holes, took at least a solid day to do, and the holes on the side there were difficult also. And then figuring out how to look at specific pieces was a big challenge also. So next we'll jump into my blog. So my blog's name, clever enough, is Job's Globe, just a silly pun there. Just the intro, hello, welcome to my globe, technology globe. technology blog. And yeah, we'll jump into my portfolio and then we can see my mid-program project. So I just go on to describe what Tinkercad is, some of the practice problems I did, and then ultimately my final project. And I include all of my code on my GitHub. Now we can see the actual code. And here is the circuits that were all involved, the Arduino, the servos, and the distance sensor. Here is the code. It is also on, you can pause the video here to look at that. That's also included on my GitHub. And then we have the 3D beast itself. So here it is. I'll go ahead and hollow it for you guys. So big task of creating this. Here we can see those blades I was talking about. Yeah, there are the holes for the servos in the middle there. I actually had to make a connecting middle portion right here to connect where the servos and Arduino were and the distance sensor. So I had to make an extra hollowed bit. And then we see too much. We see the holes of that, place it on the wall, these 3 holes right there. Yeah, and that is my project.